this section, let's take a closer look at the NLP market and major NLP applications. NLP market current interest and projections could give us insights about where to focus in the next 5 years. Just think, by 2024, NLP market is expected to grow to $26.4 billion. And the major factors are in smart device usage, the adoption of cloud-based solutions and NLP applications to improve customer service, an increase in technological investment in the healthcare industry. Now, among NLP applications, the sentiment analysis is on the top and expected to grow at the highest rate. And it is particularly because of the current increasing desire to understand end-user sentiments, clients, and also a desire to enhance the customer experiences. So the list on the left, list of NLP application, is not exhaustive, but it does provide us a sense of a wide range of NLP usage. Let's start with sentiment analysis. Sentiment reflects the overall positive, negative, or neutral opinion by person and can be quantified as discrete, 1, -1, 0, or could be a continuous scale, let's say from 0 to 1 or from -1 to 1. In a real-world application, we think of sentiment analysis as a customer satisfaction, right, and product or brand popularity, also fashion trends. If you go to cloud.google.com, you'll be able to access an NLP application demo site. The example here is taken from an article extract, and sentiment scores given, you'll see, at the document level. It can also be given at the sentence level. And you notice there's a color-coded score range legend that tells you, in this case, we're dealing with the sentiment on continuous scale from -1 to 1. And the green is a range between 0.25 and 1. So let's see what we have in this document. First of all, entire document is scored as a neutral, 0.2. The first sentence is also neutral. It's still in the range between -0.25 and 25. But what happened to the last sentence? Its score relatively high, 0.5, and it belongs to a positive sentiment. There's a couple of indicators in that sentence that you can intuitively identify or guess by just looking at the sentence itself. Do you notice what word possibly can give a higher score for positive sentiment? All right, our next task is name entity recognition. What is name entity? It is a real-world object. It can be person, location, organization. NER, name entity recognition, is a text annotation task. In NER, words or tokens are labeled into categories. So we have locations, people, organizations. Let's use the same example from a Cloud Google demo. Notice the word Google here is recognized as organization. Good. We have Mountain View, identifies location, and we also have a person here, Sundar Pichai, and it is labeled as person. And of course, from the context or maybe your a priori knowledge, you know who is Sundar Pichai. But name itself does not give us this information. Name entity linking is the next NLP task that can answer this question and help disambiguate name entities. All right, so name entity linking assign a unique identity to the name entity. The corresponding identity can be taken from a knowledge base. It can be Wikipedia or any target knowledge base used by a given application. So if we use Wikipedia, the knowledge base is typically obtained from DBpedia. Feel free to go to that link to explore more. DBpedia is a structured knowledge base extracted from actually Wikipedia. And the process of linking entities to Wikipedia is called wikification. An example from the Microsoft Azure Text Analytic demo. On the left, we have a sentence. I went to Seattle last year. And Seattle is assigned a location first of all, and name entities, and also it is provided with a link directly to a Wikipedia page about Seattle. So feel free to try out DemoSite. Coreference resolution is the next task when we link expressions that refer to the same entity in a text. In a language, we can use a variety of words to represent the same entity. We can use pronoun he, for example, to refer to Paul Allen, or we can use Paul Allen and Allen to refer to the same person, and so on. In fact, it is an important step for many higher-level NLP tasks: document summarization, question answering, information extraction. Feel free to click on the link to DemoSite from Allen NLP and try to paste your own text and see how well it identifies coreferences. Let's move to a more complex NLP task, a different level: semantic role labeling, SRL. It is a task of determining the latent predicate-argument structure of a sentence. You're going to ask me, what is a predicate? Predicate is the main verb of the sentence. So the main role is to provide representation for each sentence by identifying predicate and arguments that have relation to this predicate. The goal is to determine who does what, to whom, when, and where. The following example from Allen NLP DemoSite shows a sentence: the cat drank some milk. What do you think the predicate is? So the predicate is the main verb, drank. So we identify two arguments in the sentence. Argument 0, the cat, and argument 1, some milk. So we have two semantic relationships between the verb predicate drank and two arguments, cat and milk. But what type of relationships are they? On the left, there's a list of possible thematic roles that can be given to the argument. Agent, who typically is a subject. Patient, direct object. We have instrument that answer a question, typically how. Beneficiary will answer a question to whom, for example. And source, answer question where, and so on. Semantic role labeling is also known as a shallow semantic parsing, and definitely useful for question answering systems or for information extraction. Let's go back to our sentence: the cat drank milk. So we can ask a short question with a verb: who drank milk, right? And the answer should be very easy: the cat. And it's easy if we know the argument structure. Just by using syntactic parsing, we assign syntactic roles. We know what verb, subject, and object. But we need to identify semantic roles. And you may ask, why do we need to assign semantic roles? Let's flip the sentence and change it to milk was drunk by cat. Milk is still a patient, a direct object. The cat is still agent who does some action. So even if we change the order of the sentence elements, we still retain semantic or thematic roles. All right, there is no really universal set of semantic or thematic roles, but let's look at some commonly used. So we have on the left thematic roles, as we mentioned earlier. We have agent, experiencer. For example, John has a headache. John is experiencer, and so on. Let's take a sentence. UCD finished the 2006 championship as Dublin champions. Right, so we can identify predicate, finish, and we see it takes two arguments. It has two roles. We have UCD and 2006 championship. So we can look at thematic roles and assign, for instance, agent and probably theme. But we can also use the FrameNet data, a different type of semantic role. It is frame-specific assignment. In this case, we have to look for a specific verb finish, and we can find that it has player, and we have a game. So if you notice, the FrameNet provides frame-specific roles. So instead of agent and theme, we will have a player and a game. So you've seen the importance of semantic labeling. In fact, semantic parsing is at the core of the natural language understanding. it maps natural language to formal meaning representation. As a shallow identification of roles in a sentence, think about it enables automated reasoning if you know those roles. And it can be executed in a variety of applications. For instance, understanding executing commands for robotic navigation, of course, data exploration analysis, but think of parsing natural language to database queries and query parsing in conversational agents, Alexa or Siri. SQL queries, in fact, is an important subtask of semantic parsing. So the goal would be to generate a valid SQL program given a natural language query input and then to produce correct answer. The example is taken from Alan NLP demo. The input, which is natural language text, the query is constructed based on segments of that sentence, and as output, it should produce correct answer from database. All right, so we saw that words have semantic meaning, but do you know sentences can also have meaning between themselves? So we can analyze sentences in terms of their relation to each other. And the most important type of semantic, this type of relationship, is paraphrase, entailment, and contradiction. All right, so what is entailment? One sentence entails the truth of the other sentence. The relationship between those sentences is referred to as entailment. So on the left, we have an example of two sentences. Premise, elephant size is likely to be huge. And our hypothesis, the second sentence, the elephant is big. So far, the first sentence entails the truth of the other sentence. So we can confirm that this is entailment. The demo actually gives us 72% of probability for that to be entailment. All right, so what about contradiction? So the truth of one sentence implies the falseness of the other sentence. Let's take the same sentence, elephant size likely to be huge, and the hypothesis, the elephant is small. So the second sentence, so the truth of the first sentence implies the falseness of the other sentence. So it's contradiction. And indeed, if you look at the results, we have contradiction 64%. The question is, how do we even know the computer understands our text input? So this is another growing field of research, MRC, machine reading comprehension. Think of the evaluation test. So the ability to read and understand text and answer questions about the text, which still remains a challenging task for computers. So feel free to try one of those demos and test computer understanding. We haven't talked about different languages yet, right? And multilingual input is very common in many applications. So it is critical to be able to accurately identify language. So many language-related tasks are dependent on language-specific NLP model. LID, language identification, is used to select the appropriate tagger and also other NLP tasks, or even in machine translation model. When we translate from one language to another, to target language, from a source to a target, we're talking about machine translation. And below are example of different kind of translation. We have general purpose translation, example taken from Google Translation API. And we also have specific vocabulary translation. We need to be aware of domain-specific or geography-specific variation. And here's example for the word juice that in specific vocabulary has variation based on geographic location. So finally, if we think of question answering system chatbots, a very popular task for NLP application, the chatbot need to understand intent in order to perform an action. So natural language user input has to be segmented into utterances and identify the request and provide fulfillment. So it is a very complex task that involve many subtasks that we discussed earlier.